Hello guys, welcome back to the channel. So in this tutorial, we're going to be looking at query plan and try to explain the performance of each query. Because in the last tutorial, we looked at a couple of things. We look at subqueries, we look at correlated queries, we look at how to perform joins. So all you can use, I told you earlier on that you can use all this to achieve a certain report that you want to generate. But which one of them is the best and optimal to use? Which one of the three options gives you the best performance in terms of time and saves you a lot of time? Okay, that means it's faster and more efficient. Okay, so let's take a look at let's try to look at what a query plan is. So MySQL basically provides you what we call an optimizer plan. So an optimizer plan is which basically optimizes the query for performance. Basically, that's what an optimizer does in MySQL. So there are different provides different optimizers which help us to optimize our code to get better performance out of our code. We can use this query plan and time spent on each section of the query plan. This helps us to decide which of the best to use. Right, we can choose between whether do I to use a join, that use a subquery, or whether to use a correlated query. Which one of them gives us the best performance and efficiency? Using a query plan, you can use that to see which one is the best to choose. So how do we go ahead and analyze the query of out on see the query plan of our queries and how the estimates and the time it takes to execute this code? How do you look at all this information? And to look at all this, we need to take a look at the explain and explain analyze. Okay, so let's go. So to understand all this, let's just jump into the coding section and let's look at it. So I have my MySQL workbench open up here. So I have all these correlated queries and all the joins. So let's go after just move this down because we'll come back to this code just in a second. So for now, let's just move it out of the view. And in here, let's go ahead and simply select the customer information. I'm going to say select. Let me just make that up. Okay, so select. I'm going to select everything, all the columns or from the employees table, from the customers table. And let's just go ahead and execute this and let's see. So I'm going to go ahead and execute this. And once I execute this, it's going to return to me a list of all the employees, right, as we expect to. Right, good. So once we have a list of all the employees, we are good to go. So now let me just also add in a where I want to select the employee, whereby the employee name matches this one right here. So let me try to select the name there. Okay, so I'm going to go ahead and let me just also, before I even execute this, let me just go ahead and try to let me just put the explain keyword up here and let's see what's the query plan of this. I'm going to say explain. Okay, so explain. Yeah, that's like that. And then once you put explain, it's going to give you an explanation of what the optimizer chose to execute this query. So if I run this, you can see we have right here, we have the simple explain information. So you can take select type is going to be simple. Customer is performing this execution on customer. The type is all. Possible keys, we don't have any of those. And then you can see number of rows that we went through, 122 rows. Filtered extra, this is the information. You can see all the information, but this isn't really not helpful to us, right? So okay, let's just leave it this way and let me just go ahead and try to do something else. Let's actually add a where clause here. So let me just say where we're going to say where customer name. So I'm going to say customer name is going to be something else. So customer name is going to be equals to the name that I just copied, right? So paste it right there, and then I can end that to the semicolon. So once I have that ended, I can just go ahead and execute this again. Let's see. Now filtered, you can see filter previously was just, if I run this query, filter was 100 because it didn't filter anything. But now whenever I execute with the where clause, now it changes to become 10. So it did 10 filtering. So it went and filtered 10 different rows. Okay, out of 122 rows, we filtered 10, just 10 different rows. So filtered. So this I can this that was filtered. You have to get for us the employee with the specific name, right? Okay. Yeah, 10% of the data was filtered as I mentioned earlier on, and the table scan basically like performing the scan on each row of the table is called the table scan, and it was performed on 122 rows. So explain alone doesn't give us much details. What about explain? Let me just go back here. We also have explain format equals to 3. What does this really do? So this will show us the query plan and an estimate of the cost, like how much time it's going to take. This is going to be an estimate and not the actual value. So let's go ahead and try to do explain a bit of this. So we're going to say explain. We're going to say format. So we're going to say format. Format is going to be equals to 3. So let's say 3 right here. So once I have this done, I'm going to go ahead and select this and then run it again. So now you can see this, we have it right here. So just select on it and just say open in viewer, and you have the binary information. Just go on, click on text, and that's going to show you an estimate of this query. Basically an estimate that the query planner is using. So you can see filter. So we're going to the customer names equals to this name of this file. That's trying to filter for. So the cost it took, the cost is 12, and the rows filtered is 112 rows, and the table scan was performed on 12 on the 122 different rows, and the cost was just 12. Okay, 12.5. I think that's the milliseconds if I'm not mistaken. Yeah, so that's basically what there we can see the table scan and all that information. So good, that's what format explain does. But format explain also has some issues. It doesn't really tell us if the estimates are correct. It's just an estimate, right? Not an actual value on or basically an estimate. So how can you get the actual value? And that's why you have explain analyze. So if I go here and just simply say explain analyze, so analyze just like this, and if I execute this query again, it's going to now give me if I go and say a view, open in viewer, now this is going to give me now an basically an actual time that is going to take, and not just an estimate. So that's the difference between explain format equals to 3 and explain analyze. And explain analyze gives you not just an estimate but also the actual value. Okay, so you can see the actual time it took was this amount of time for the total, but the amount of time to take to get all the rows is this amount of time right here. Good. So this is the time it took to get the first row, and this is the time to get all the remaining rows. And yeah, that's basically this returns to us one row. And the table scan was performed on how many rows? On 122 rows. This in just one loop, one iteration, and it took this amount of time to get the first row and this amount of time to get the remaining row. So these are just milliseconds. So 0.318 millisecond, and this is 0.189 milliseconds. So you can see all that information right here. So by using this, you can get much accurate information from this. So if you just zoom in, you can see that bigger. I hope you guys can see it even bigger. So this gives you actual information on that filtering, and you can see the actual time it took and not just an estimate. So you can see these are all estimated values, and this is an actual time. And you can see this is 1.84 milliseconds for the first row, and this was for all the remaining other rows. So that's basically what we can use the explain analyze as for us. So now that we have seen all this and how all this works, right? Now let's go ahead and try to see how we can use this. Okay. Okay. One thing I didn't explain to you. Let me just go ahead and zoom back in here and explain to you this in a much more detail. I think I missed something right here. So this is the on actual time. On average, this is the amount of time to retrieve the first row. Okay. Average, the reason why I'm saying this is the average time is because we have loops, right? We have loops, right? Some queries must have more than one loop, more than 3 loops, more than 4 loops. So on average, this is the amount of time it takes to get the first row, and this is the amount of time to take to get the remaining row on average, right? Because we have this concept of loops. So some of them might have different loops, and this right here are just the estimated values, and this actually the real time, the real values, and this one right here are just estimates. Okay. So yeah, this is on average because of the loop concept. Okay, so that's one thing I didn't mention right here. Okay. Okay, so once we have that out of the way, let's go ahead. I have these two queries queries right here. So we have the join and also the correlated query. So which one should you choose in this specific case? And that's why you can do the explain analyze to see which one of them is more optimized for your use case. So if you just write query explain analyze on top of the query and then go ahead and execute the query, it's going to give us the query information. So let me just go ahead and open this up, make this full screen, and then try to zoom in. Okay, so on average, it took this amount of time to get the first row, and then this to get the remaining row, right? 0.019 seconds, around 0.02 milliseconds, sorry. Okay, 0.02 milliseconds, because it's doing some filtering, it's performing table scan and then index lookup. Okay, and is doing all this in all 7 loops. So you can see on average it's taking this amount of time, right? And to get the first row, and this amount of time to get all the remaining other rows. Okay, so you can see that information right there. So you can say that or the total cost of this will be the whole thing takes this amount of time on average to get the first row, and this amount of time to get the remaining. So 0.01 174 milliseconds perform the whole query, right? Okay, so we have that information right there. So you can actually compare this information with the one that's going to be generated from the this one right here. So you can just say explain. So let me just look at this one more time to get the value that I want. So let me just get the value that I want. So let's see the values right here. Let me just make this bigger, so and just try to zoom in so that you guys can see better. Okay, there we go. So So this is basically the time that is taken, and you can just go ahead and simply, let's just see this value right here. It takes around 0.174 milliseconds. So 0.174. Okay, and let's go ahead and try to use explain analyze on this as well. So let me just undo that I just did. Let me see. So here, let me try to zoom out a bit to see. So we have the correlated query, and you just say explain analyze. So explain analyze, just like that. And then we also have explain analyze on the correlated query. We can also put it here, explain analyze, and this took about 0.174 milliseconds. So now let's go ahead and see the correlated query and how much time it takes. So if I just go ahead and select this and execute this, and let's see how much time this one took. And this one took around let me just zoom in again. This one took around 0.25 0.257 milliseconds. So you can see that in this case the join is much faster than using the correlated query, because the correlated query takes 0.27 257 milliseconds, while this one takes 0.174 milliseconds. So you can see that the join is much faster and optimized for your use case, better than the correlated query in this specific scenario. This does not mean that the correlated query is bad or anything. In another scenario, it might be faster than but than using the than performing a join on the two tables. So again, this is the whole point, to help you to analyze and decide which of the options to use. Right? You can always just write explain analyze and then get the time performance, estimated value, and the actual value of the performance, and then decide which of the two queries to use. So in some cases you are looking for optimal code, right? So just write the code for joins, for subqueries, for correlated queries, and then just run them and see which one of them gives you better performance, right? Depending on how much time it takes, and then from there you can choose, right? Because there's no one best case for all, one fit case for everything. It depends on what you're trying to do, and that's why you have to know how to analyze the query. So that's all for this video. Again, you can go and read about more about this in this website right here. If I remember, just I'll keep the links in the description of the video. If you guys have any issues, you can let me know. Okay, so that's all for this video. Again, if you're new to the channel, please kindly consider subscribing to the channel, liking this video, and sharing this content with anyone who you think might find it helpful. Again, you can also help me by buying me coffee. The links will be in the description of the video. Thanks for watching, and see you in the next one. Keep safe.